Hey everyone, hope you guys are doing well. In this video, we're going to create an AKS cluster using Terraform. So this is kind of the infrastructure kind of looks like. We're going to have a subscription. Within that, we're going to create a resource group, and then we'll create a vnet and AKS cluster. So in the diagram, you're seeing that there's a manager resource group. AKS does create a manager resource group that other resources that it needs, like public IP, network security group. So that will also get created, and other than that, we're gonna create two node poles. So the one we are required to have the system node pole, and we're gonna also create a user node pole that we will use to deploy our app, and the app will be exposed on the node public IP address, and then we will access that app. Before I start, I want to let you guys know that I do have a repo that contains all the code that I'll be utilizing in this video. If you go into, I'll leave the link below in the AKS Terraform directory. Within that, we have all the Terraform files that I'll be using. And then you also are gonna have manifest file, the app that we're gonna deploy later on once our cluster is created. And there's a README and the infra diagram available for you. And the temp file is something that I'll explain it once we get to the point. It's just sitting there for a convenience purposes. So what I'm going to do, I have cloned that directory or repo on my computer, and you're seeing all the files that have been loaded up here. So I will delete all of them, and we will create as we progress in this video. So let's delete all of them. Okay, so when we start with the Terraform, you're just gonna make sure that the Terraform is installed on your computer. So go to the AKS directory, or it doesn't have to be this directory. So I'm gonna create, the first one is going to be provider.tf. I'm gonna copy the content that's sitting here in the directory, and I'm gonna duplicate it and move it to another screen, and so that's how I'm gonna prepare the file. So preparing it from the scratch, writing it as we go, it'll take forever for me to finish the video. So I'm gonna copy the content from the repository, and I'll explain what I'm doing. So the first, we gotta configure the provider. So we will gonna copy and specify the provider. So I'm using Azure, and I'm specifying that I'm going to use the Azure provider. You're going to specify the two blocks. Once you've done that, in the terminal, I'm going to come into the terminal, and if I list, I only have one file. So the first thing you got to do, you got to initialize it, Terraform, so that it downloads the module that it needs to work with Azure. Okay, so it's been successfully initialized. The one thing I want to tell you guys, with the version I have explicitly specified, you could exclude it. If you do, I think it'll download the latest module for you. So the next thing we're gonna do, we're gonna create a variable file. So this will contain all the variables we will use for the resources that we're gonna create. So the first, we're gonna create our virtual vnet, and that's something that AKS cluster will utilize. So I'm gonna bring in all the variables that I have it for vnet. So the first one is a resource group. We're gonna create the resource group, and then the region, and the vnet CIDR, and the system subnet prefix, the CIDR for it. So like the subnet that we're going to use for system node pole, and then there's a subnet that we're going to use for a user node pole, and the ports that I'm allowing on network security group that I will attach to my node pole that will be serving my app. And then there's essentially letting know where the traffic is coming from. So save this variables, and now we'll create another file called vnet.tf. So we're gonna specify our vnet resource. So I'm gonna copy the entire content. So the first, we are creating the resource group using resource from a Terraform resource, and then we are vnet. Again, we're getting the values from the variable. So I'm going to open it to the right, and we'll you could see how we are referencing the values. So then resource name is coming from, again, from the variable, and the vnet location also coming from the resource group, and then the resource group I'm using for the vnet, and the subnet, system subnet, that as prefix is coming from the variable here, and the vnet I'm going to use, I'm just referring it from the vnet resource I'll be creating above. And similarly for the user subnet, and then I have a network security group, I'm just specifying it and then associating with application security group, and that's what I'm going to attach to my node poll. You could essentially attach the network security group directly to the node poll. I just prefer to have it application security group. It just kind of makes it convenient down the road if you want to add multiple nodes to the application security group. Okay, so now then there's a security group rules that the traffic that is allowing from. So the ports that it's going to allow from are specified in the variable. This is the 22 port SSH. I didn't need it, but I just put it there just in case I need to SSH into my nodes down the road. Of course, you got to configure your nodes accordingly when you're using it for the AKS cluster, but I'm not focusing on that one. But I just have the port open, and then there's another port 311. That's where my port, the manifest that I will be deploying later on, will be exposing at. So we're making sure that that port is accessible, and we can reach our app whenever we end up deploying. So that's that. So vnet resource is somewhat ready. So what we're gonna do, we're gonna come in here and run Terraform plan. So one thing you're gonna notice that here we do not have some sort of a authorization set up to Azure. Like, if you notice, I specified the provider, I specified the resources and everything, but my Terraform doesn't know what Azure resource is supposed to be talking. And so that's where we're gonna go to our portal, create an app, service principal, and give enough permissions and assign it to Terraform, so Terraform could access that and then create the resources on your behalf. So to do that, first thing we're gonna do, we're gonna register an app. So I'm gonna call it test DA. You could leave the options as it is, unless you're multi-tenant. I'm assuming most of the people are going to have single tenant, so register the app. Once the app is registered, you're going to go into subscription, and within that, go to the IAM, and now you got to allow add a role assignment and privilege administrator. So I'm going to add a contributor role, and what service principal you want to add to, you just type in DA. Looks like it's not loading up. Let me refresh this page real quick. So administrator privilege, contributor, and what's the colon? Did I call it? Oh, I call it test DA, my bad. So select that application, and so now that would have a contributor role assigned to it. So it could make all the changes on your infrastructure. Essentially it won't be honored and won't be able to delete subscriptions and stuff like that, but it would have enough permissions to make changes on your infrastructure. So now coming back to the application that we created, now we're gonna create a secret. So coming here, secret, and click on new client secret, and how long the secret should be valid for. You could leave the default, and description would be whatever. I'm just going to leave it Terraform, and now load this value. So gonna go back to our cloned repo, and here you notice the temporary sh file that's sitting in the repository. So I'm gonna put in the value here for the secret. and then it's expecting other values too, subscription ID and tenant ID. So go to subscription, here I was. So I'll grab my subscription ID. Now it's gonna need the tenant ID, so that's something you could find it in your applications overview page. So this is the client ID and this is the tenant ID. I'm gonna make sure I got the values right. Yes, looks great. So one thing to point out that the variables, environment variables you're gonna store in your on your computer, that it gotta have a specific name. They gotta start with ARM client ID. So if you just save it as a client ID, Terraform won't be able to read it. For Terraform to read this service principal credentials, you gotta name it, the prefix gotta be ARM. So now I'm gonna paste this in my terminal so that the environment variable would be added. Okay, so now if I run Terraform plan again, this time I should be able to communicate with my Azure portal, and it will say that, yeah, this is where I'm gonna create the resources and everything. So yeah, so now this is a Terraform plan telling me what resources it'll be creating. So it's gonna create vnet and the subnet, security group, application security group, the subnet role, and everything that we have specified in our Terraform file. So why don't we just go ahead and create it. Confirm. Okay, so our 8 resources have been created. It took about I don't know, less than a minute or so, and our resources vnet is created. If I go to my Azure portal and go into resource group, the new resource group would have been created, and in here I'll see that this is the vnet that is created. The CIDR and everything will be as we specified in our Terraform file. So now next thing we're gonna do, close this file, and now we're gonna create our AKS cluster. So let's do that. I'm gonna copy the entire content from the repo. So we're gonna create a new file. I'll just name it AKS. Oops, did I create a directory? Looks like I did. So just bringing everything in here, and so before I do that, I forgot to add the variables that I have it for AKS clusters. So let's bring those into. Okay, so our variables are in place. So if I open my AKS file now, I shouldn't see all those errors saying that the variable is not present and stuff not. So I'm gonna open this file to the right and the variables to in the left side. So let's review this a Terraform file. So first thing we're using a data to import the configuration that we will use whenever we creating the cluster. So the first thing we're gonna do, in case we need it, actually I don't think so we're gonna need it, but we'll see. So the first thing we're gonna go to looking the cluster variables. So we're gonna create a cluster resource. Using cluster resource, we're gonna name the cluster and the region that's gonna go, the resource group, and the DNS prefix. All these values are coming from our variables, the file that you see open on the left. And then the Kubernetes version, the version I'm specifying is 130, and the SKU tier, like, you know, it's depending essentially if you want to have a premium support for your resource or not. This is I'm setting it to free. I believe my default value is free. I don't want to have any sort of a premium or standard. The pricing will vary depending on what kind of SKU tier you pick. And then automatic upgrade, like, you know, when you're doing the cluster upgrade, you want to have it the node image updated or stable or rapid. How often do you want to have a automatic upgrade in place for your cluster? cluster. And then the cost analysis is just an additional feature, is set to default by false. The reason I specified it so that you just know what you're configuring your cluster. So this is one of the beauty of when you configure resources using Terraform. You get to know all the properties related to your resource that you're creating, not just the cluster, the other resources we create. So that's one of the reasons I really like creating resources using connecting the APIs or Terraform or even using CLI. You get to familiarize with the properties of the resource that you're creating. And the next you have tags. So I'm using environment D, a demo tag for it, and then the identity. So the identity is a system assigned. You could use the user managed identity, then you would have to create the identity and assign it to the cluster. The drawback is that when you assign system assigned identity, cluster is going to create the resources that it needs, what we saw in that diagram, that whatever the resources it needs, they would create it only if you have the system assigned. If you have a user assigned, then you'll be responsible for creating some of the other components that the cluster might need. So after that, then we're gonna configure the system node pool setting, the nodes that we're must gotta have it for cluster to work. So the first thing, got a name of the system node. Before I get to that, there are a couple of properties on how the node OS should be upgraded. This is kind of like a node image, so not just the security patches, any sort of a major updates coming for the node, it'll include and update those. And we will have our maintenance windows, we will talk about it once we go over this file, yeah, so updates the node images. Other than security, the major updates will also get applied to whenever we're doing the node updates. So the node resource group, this is the managed resource group that what you want to name it, that the cluster will use. So this resource group, managed resource group, will get created. So now we have a default node pools properties. So first the name, you can name it fancy, you gotta keep it lowercase, and it can have spaces, I believe. So just lowercase, no spaces, just the letters. So that node pool name, and then the size of the VM that we're gonna use. So I'm keeping it simple, not too fancy, D2 PSV6, and then the kubelet disk type OS. So this is what disk a part should use whenever they have some sort of a temporary storage that the parts create or generate logs. So it's kind of kubelet related data. OS in this case is okay, but in some cases you may not want to have it. If your parts are creating too much logs, you probably wouldn't pick OS a disk to have those logs stored. And the disk type, so it should be managed. This is default. And then you have a maximum part. You can have it in a node. Setting the value to 100. And then the auto scaling should be enabled for the nodes that we'll be creating, and I'm specifying yes, I want to have the auto scaling enabled for this node pool, and the type is the virtual scale set, and the maximum node, this settings only apply if you enable the auto scaling. So the maximum count could have 4 and minimum 2, and at any time we're gonna have 2. And the node public IP, so this is a system node polls. I don't want to have public IP enabled. That is a default value. However, when we create our user node pool, we will enable this one. So the scale down, so what happens when the VM's getting scaled down? So I want to have them deleted. So critical add-ons, so I've enabled it, so only like a critical workload will be deployed on the system nodes. If I try to deploy my app, it won't get deployed. Any sort of like Azure CNI or DNS, all those kind of core DNS, all those parts that'll be deployed on the system node pool for sure. But anything that your application, specifying that I only wanted the critical workload to be added to this system pool. And then the disk size, so I'm specifying to 50 gig, and the provision, and then you have the OS that you want to use. The Linux is going to be Ubuntu, and the subnet ID, this is being referenced from the vnet that we created, and I'm just referring to the system subnet. And then the upgrade settings, so this is kind of like, you know, whenever you're doing the upgrade for the cluster, the drainer time is like 0 minutes, the soak duration is minute, the maximum, the number of nodes, or the percentage you could have it in place when you're doing the upgrades. I set it to 10%. And there are other arguments I didn't explore. It's kind of like a Linux OS config. If you want to configure your swap or even fine tune the kernel, you could use that to use that property to kind of fine tune your kernel. And then you have a FIPS. If you have a security requirement, you might want to enable FIPS. I think there's this thing situation that, you know, if you wanna enable FIPS, you gotta pick certain type of VMs. You know, you just, so they're not available with all VM types that we pick. And then there's a kubelet configs, like, you know, how many logs the pods could generate, and the maximum processes per pod, things like that. So this is where, you know, if you end up using OS disks type, and this is where you just kind of configure it, like, you know, how you control your containers and how they're generating logs and stuff like that. And then run commands. So defaults, if you want to run admin tasks on the VM, so you could do that. So run command is a feature from Azure, so if you want to enable it. And then you have a storage profile. So this is I'm just enabling all those drivers just in case if I need to connect these VMs to blob storage or disk storage or the file driver. So this is for Azure file and attaching Azure disk. So if I'm attaching all those things to, want to attach to my parts, I want to have those drivers or CNIs in place. So then the support plan, so do you want to have it Kubernetes official, or do you want to have a long-term support from AKS? So it depends on, like, how you're deploying the cluster and what kind of support you want to have in place. So then there's autoscaler profile. This is related to the autoscaler that we enabled above, and how are some of the properties. So max graceful termination seconds, like, you know, how much time it needs before it gracefully terminate your server. This is kind of like a 5 minutes. It's need 5 minutes, so it's gracefully turn off your or terminate your instance. And the maximum node provisioning time, so I'm setting to 15 minutes, and the maximum unready nodes. So the reason we specifying this value is you don't want to have nodes keep popping up, and in that case, if you imagine you have a scenario, 2 nodes trying to be provisioned and they are in unready state, and autoscaler is thinking, oh, you know, there are only 2 nodes ready, I need to put in 2 more nodes to add to the cluster because cluster is needing more nodes, but they are becoming unready. So, you know, you don't want to have too many unready nodes. So you want to stop it at a certain time period. If the nodes that are being created, if they're not getting to the ready state, you want to stop it at a certain time period. So in my case, I have it set to 3. So the 3 max unready nodes could be when the autoscaling happening, and the scale down delay after add-in. So once you add a node, how long do you want to wait before you scale it down? It's 5 minutes. So skip nodes with the local storage, sure, and the skip nodes with the system parts. So if you want to skip the certain parts that with the system parts, you can skip that. I'm set it to true. And then there's a workload autoscaler. So this is something that is different from the nodes autoscaling. This is a pod autoscaling. So instance, like, you know, where pod is utilizing too much RAM or the CPU, once you enable it and the new pods are coming in, and it will utilize the resources for the new pods and the existing pods. So we'll maybe deallocate and allocate the RAM or the resources accordingly so that it could facilitate more pods. Of course, if the resources are required by the pods or you explicitly specify, it won't be able to do too much. But if you dynamically pods are getting that resources from the nodes, it would try to autoscale it and make it room for other pods that are coming into the node. And there is a pod network setting, so like how the network profile should be. So the pods, I'm gonna use the Azure CNI plugin, and the policies, the network policies, Azure too, and the mode is bridge. This is by default, so it kind of acts that as a bridge. The nodes act as a bridge. Then the network type plugin mode is overlay, so we're not gonna use Azure subnets IPs. We're gonna use overlay network, and then the outbound type is going to have a load balancer. So this is kind of essentially the NAT for the pods. Then there's a pod CIDR, so specifying that the CIDR for the pod network, and then the service CIDR and the DNS service IP, so we're specifying that value, and the IPv version, IPv4, IPv6, the load balancer SKU, like what kind of load balancers you want to have in place. I'm setting it to standard. And then the private cluster enabled, so I think I disabled it. Yeah, so the private cluster is not enabled. So the reason is that I want to access that cluster once it's created from a laptop. I'm not on that subnet. If I'm in the subnet, I probably will set it to the private, so that I don't want to have it exposed to public, so people could access it over the internet. Of course, you gotta have RBAC and everything in place, and Azure CLI and everything, but you could limit your cluster to privately, so that nobody could access over the internet. But in my case, I do need to, so I set it to default. And then it's come to the security related stuff, like do you want to enable the Azure policy? I've set to default. I'm not using Azure policy. And then the local account disabled, I think I've set to false. So I'm using the local accounts. I want to use the local account to manage this cluster. If I'm using Azure RBAC, I probably would maybe disable this one. If I'm managing the access separately, then I would consider disabling this feature. So now, remember we talk about when we set up the nodes upgrades for cluster and for the nodes. So this is where we specify the maintenance. So there are going to be 3 type of maintenance windows. The first one is AKS. So the control plane, whatever the settings that how often that the maintenance happens on this one. I'm specifying the allowed value, and it happens on Thursday, and then what hours, so 1 a.m. to 2 p.m. So if I specify 3, it would means that 3 to 4. So any value you specify, it adds an hour duration to it. So you could add multiple to it, so that your AKS stays up to date. So this is something that happens behind the scene, you probably wouldn't notice. And then you have Kubernetes maintenance itself, like and then coming with the Kubernetes versions or patches that coming in, and how often you want to have it. So it's a relatively month. Duration is kind of like 4 hours the second Sunday of the month, and starts at 2 a.m. and I'm setting the UTC offset, so just kind of making sure that it falls in my time zone. And when is it not allowed, I specify the Christmas time around, like if second Sunday falls around this time frame, I don't want the update to happen around that time. We can add multiple or recurring, so this is only once gonna occurs once, so you can set it to recurring. So this is similarly for the nodes of the cluster that we are deploying. So how often the updates for Ubuntu will apply it. So it'll be weekly, and duration for 1 hour, interval is 1, and the day of the week is Tuesday. Again, it's starting on the second at 2 a.m. and I'm setting the UTC offset. Again, the recurring can be enabled, so I'm just setting the time that when it shouldn't do the updates. So then the other features, like if you have stale images sitting on your cluster on the node, you want to have it enabled, you set it true. And how long those what is considered stale, so like 7 days, any images are sitting there for more than 7 days, I would consider them stale, and I want to have them cleaned up. So there are other options that I want to quickly specify, so that if you want to use the Ingress application gateway from the Azure, you would use this attribute to specify that value. So if you want to use the key, you can also use a key vault secret to just kind of have to store your secret. So it would download the key vault CNI and everything like that, and then you could store your secrets on a key vault. And the kubelet identity, so this is only with the user managed identity. You're going to create the user managed identity and then configure the kubelet identity. And then there's a Microsoft kubelet identity would be used by pod to connect to your resources. Microsoft Defender is essentially to kind of collects the log. You're going to create the log analytic too for the Defender to collect the log from. The monitoring is kind of like Prometheus profile or Grafana and stuff. So OpenOIDC enables, if you want to have OpenOIDC to for then eventually enable the workload identity and stuff like that. So you will enable that. So OMS and Open Service Mesh too, and the Service Mesh profile, all those additional features that you want to have it. There's an option for the custom certificate. So this is a certificate will get loaded to your nodes that so that they already have a trusted certificates in place that they're gonna need it to talk to certain applications. So of course for the Azure RBAC, and then this Linux and Windows profile. So when you're creating the nodes, you can specify their SSH key and the for Windows profile, like admin username and a password. And there's a key management service too. Again, you're gonna need a user management identity with it. So this will be used to encrypt your secret. So not storing your secret, just to encrypting it. So now, so once we over it, so sorry, it took a little while. So now our AKS cluster is in place. So the resource is in place. So let's go to terminal and create it. Creating Terraform cluster, AKS cluster will take a little longer. So I want to say maybe about 4 or 5 minutes. So once I confirm it here, it's just saying that it's going to create one resource and giving you all the properties that we specified, and some of the values will be known once the cluster is created. So I just have to confirm by typing yes. Once I enter in, this will take, like I said, 5 minutes. So I'll wait for this to finish. Once this is done, we'll continue. Okay, so our cluster is created. It took about like 4 minutes and 25 seconds. So let's go to our portal and check it out. So going to resource group. So it's gonna be the same resource group, and I come in here and this is the cluster. Okay, so everything is in place. If I come into my monitor, its monitoring isn't enabled actually, so it'll give me a bit of an overview of what is happening. And let's go back to cluster again. So coming to the settings, so node poles, you're gonna see there is a system node pole and has 2 nodes in place, 2 are ready. So if I come check it out, the workload that I have in place. So this is gonna first I'll look at the upgrade settings. So it's exactly how we specified. So node images will be updating, and everything, the networking side, like the vnet that it'll be using and everything. So so I wanted to review the resources. So coming here, so this is the kube system and the workload, the nodes that will be deployed here. So it's everything related to the critical, even the connectivity agent, autoscaler connectivity, the core DNS, and even the Azure CNI. I think I can't remember which one is it, but yeah, so our system workload is in place, and I think we have about 5 services in place too. And now, okay, so now if we want to connect to this cluster, it's super easy. If I have it my Azure CLI connected to my terminal, all I have to do just download this credential, copy this command, and paste it here, and I should get, I think I'm not logged in. I'm gonna use the browser method today, log into my Azure, and okay, so just select it and then connect to that cluster again. And if I do kubectl get pods, it's gonna, there's nothing in that default node space. So if I do this, and here we are, like all of our there's the Azure CNS that I was talking about that is in place, Azure IP, Azure NPM, all those kind of stuff, like, you know, the options that there is a CSI for the blob storage and for the Azure disk, everything is in place. So yeah, so as we configured, now if I want to, my parts want to talk to blob storages, Azure disks, all is in place. So now what I'm going to do, I'm going to clear this one and let's quickly list our nodes. So not something I wanted to do. So we have two nodes in place. Those are our system node poles. So now we're gonna create a user node pole. So what we will do, we're gonna go back to our clusters, Terraform files, and we'll create another file. We called it user node pole and tf in here. So name it to tf, and I'm gonna copy the content of the node pole. So bring it here. So now it's referring to the variable that I may not have defined yet. So let's grab that variable as well. So the variable is just the name of the node group that we're creating. Just now the variable is in place, that it shouldn't give me an error. So let's open to the right and have variable file. There's not much to explore this time, so the settings are going to be pretty much similar. So variable name, the node pole name is what user pole, and the cluster ID we're referencing for the cluster that we created in the AKS file. So since the cluster is in place, so we'll grab the ID and the VM size. So this is the variable that we used for our system node pole, and I'm specifying the size to be the same. So this time, where to go? I'm just gonna quickly find that one. So this is gonna be the size of VM, and this time it's gonna be using the kubelet disk type is OS2, the disk type is managed, the maximum pods I'm keeping the same as system node 100, and the auto scaling is enabled. And similarly, it's gonna mode set to user, and maximum count is 4, minimum is 2, and anytime it's going to be 2. And this is the time we enabling the public IP, and this node's going to have public IP, and then we will use it to connect to our app. And scale down is deleting it. The disk size is 50, and again coming from the variable. And Ubuntu OS type is Linux. This is default. You could specify to be Windows. One thing point out that when you're creating system node poles, you only gotta pick Linux, you can't pick Windows. But when you're creating your node pole group, you could pick Windows for your workload. And the subnet, I'm using the user subnet, and that has certain ports allowed. And then the network profile. So this is may or may not required, so I'm telling that on the node itself, like particular port should be allowed on the host, and it's port 22 and port 311, and then I'm attaching the application security group. Remember when we created the vnet, we created application security group that has network security group attached to it, and yeah, then the ports that we allowed will be allowed, and allow the traffic to this application security group. So this is the configuration for our node pole. So let's just run Terraform apply. I'm confident about the config, so typically you want to run Terraform apply before you run Terraform plan before you run Terraform apply. And this time it's just checking the state of my configuration. It's telling me that everything is looking okay, no changes, but I have to create a node pole group. So that's what's gonna happen here. So I'm gonna confirm yes. So it will, this one doesn't take too long, maybe about a minute or two. Once this is done, we'll continue. Okay, so our node poll is ready. So it took about 2 minutes and 20 seconds to create it. So if I go back to my portal, let's go back to the portal and I go back to node polls, and I should see another one. So I'm gonna go back to the terminal, and if I clear this window and get kubectl get nodes, I should see the 2 nodes are wait. How come other ones aren't popping up yet? Wait, let me see if they're ready state. They're not in ready state, so they're still getting to the ready state. So let's just wait here real quick, see what's going on. Not ready. Okay, so they're ready. I just had to wait for a little longer, maybe a minute or so. Now the nodes are ready. I just had to refresh and they're ready. So some of the parts are deployed as well. So if I do kubectl get nodes now, I should see those nodes. I just had to wait a little longer. So if I do kubectl get pod, and there's going to be none in the default namespace, so some of the parts will get created in the kube system for this even node poll. So the things that we have specified, like we're using Azure Disk and Blob, all those CSI drivers will, the parts will get deployed to the user node poll. So once we have our parts, the user node polls are ready, now we're ready to create our app. So if I go to my manifest folder and there is called block app YAML, just copy this one. So I'll talk about it, what's in it. So I could create it from here. I'm just being, let me just do that actually instead, and kubectl apply. I was just lazy. I was gonna go to the portal and it just create and apply the YAML here. It's just, I occasionally do it. It's just for fun when I'm working in non-harming clusters. So this is just fun. So I'm just gonna do it the regular way. So kubectl apply f and the block YAML. So now our deployment is done. So if I do kubectl get pods, and they are being created, if I do void, you would notice that they will be deployed to the user node poll VMs that we created. So the reason is, again, if you remember that in one of the configs that we did for system node polls in was it AKS? Yeah, in AKS we made sure that the system node poll only takes the critical workload. So it's not going to have your user apps deployed. So once this is done, let's just do kubectl get nodes. So now I'm gonna grab IPs of my nodes. So this is where it comes to user node polls. This is my public IPs of my the nodes that are deployed. So I'm gonna grab this one real quick and go to the browser and type in 311. That's the port that is exposed, and there we go, my app is deployed. So yeah, so that's pretty much it. So that's all I wanted to cover in this video. So again, everything that I covered is available in the GitHub repository. I'll leave the link below for you guys. If you find anything that I might have missed or I should have included, please leave a comment below, and I'll try to I make sure that I cover in the future videos, or I'll make a separate video for a particular topic that you might be interested in. Once you're done, don't forget to destroy your resources. So I'm gonna quickly go to the same folder, just making sure my save file is in place. So if I do Terraform destroy, it'll destroy all the resources that I have in place. So this will take about I want to say a minute or two, and whatever we have in the portal will get cleaned up, essentially what we created so far. just wait for a few minutes to this to finish. I think I have to confirm. Yes, I have to. So I'm deleting 10 resources and just wait for this to finish. Okay, so all of our resources have been deleted. The cluster alone took about 4 minutes and 58 seconds, and destroying the resource group was 16 seconds, and the virtual vnet 11 seconds. All that irrelevant information. One thing I'm gonna do before I finish this video is that we're gonna make sure that if you have, like, you probably wouldn't be in my position, but if you, for a reason, you may have exposed your application secret key, you probably want to delete it. I don't want to have it enabled. You probably notice me that this application have contributor roles, so I don't want people to stealing the key and connecting to my Azure and maybe, creating the resources. I don't want to have them created. And with that's it with this video. The cluster is cleaned up. I hope it was informative. If you liked it, please consider subscribing, liking the channel, and thanks for watching.